Good evening, all. Good evening, all. Yeah, today's webinar topic is IoT using Raspberry Pi. So, organized by the Saint Francis Institute of Technologies. So, it was established in a year of 1999. A view of to creating an engineering degree institute to fulfill the long-felt public needs of a institute and excellence in a Borivali. So, the stiff. So, if you want to make it. It has a 5 UC programs and 2 PG programs in the most coveted disciplines, considering both institute needs as a public preferences. These courses would be lead to award of the student Bachelor of Engineering in the Computer Engineering, Electronics and Telecommunication Engineering, Information Technology, Electrical and Mechanical Engineering, and Masters of Engineering, Master of Engineering, as well as PhD Technology in a Computer Engineering and Electronic Telecommunication. And the St. Francis Institute has an local chapter, student chapter at IETE, started in 2008. The objective of this student forum as to awakening them towards the public requirements, people requirements, the technological developments in the field of electronics and telecommunication, and uh, to provide them a platform to develop their technical and managerial skills by organizing the various technical events such as seminars, workshops, competitions, and then technical paper presentations and project expos, etc. At present, there are 37 activity memberships in this chapter. Miss Shilpa, Chairman, Assistant Professor in EXTE department, in the coordinator for this chapter. The endeavor of IETE shift students is to spread the awareness about the state of the art technologies used in industries as well all around the skills engineering, keep it in a mind to the interest of the student. So, and they started a program, the each one technique one. So the following objectives are being each one will provide you the host under IET and STIP to the student membership of the committee to encourage the bright student to impact their knowledge to their fellow members, to improve the platform to the students to develop their technical and the managerial skills by presenting on various technical topics, to update the students with the technological developments in the field of electronic and technologies, telecommunication. So this webinar series, each one teach one, will be initiated by our own as a committee, a membership. The topic, yeah. So this is all about the San Francisco view. So today let us get started our topic IoT using Raspberry Pi. So Internet of Things. Okay, so, we are listening so many of the workshops, so many of webinars, so many of things from past 10 decades. We are very aware of Internet of Things, but still there are drawbacks and there are some requirements to. It is not completely ground. It's not completely implemented. Now in our day-to-day lives, somewhat implemented in the form of smart TV, smart home appliances, but still there is improvement we need to do in this sector, the IoT field. So it's like a what is the main aim of an Internet of Things in the sense to make everything smarter. For suppose if you are taken in your room you have so many kind of devices when compared to the humans. So for communication purpose we need to interact, and every device can able to think, and it should give some instructions. Every device should talk to me, like my TV should talk to me, or my water bottle should talk to me, or my dustbin should give instructions to me. My in a garden my plants, it should talk to me. So all these things we are seeing. But if you want to build an IoT in industrial aspects or industrial things, so there are some recent things we require, the latest things. So all these things today we are going to see. So first I'll give you the basic. We'll start from the scratch. So introduction to the embedded system, introduction to the Raspberry Pi, and then architecture of a Raspberry Pi device. So why we are moving towards a Raspberry Pi, all these kind of things we will discuss, and I'll give you a brief description of an architecture and what are the protocols presented over there, like MQTT protocol and SMTP protocol. So these architectures we are going to discuss, and later introduction to the GPIO pins. Okay, these are the topics today we are going to see in this webinar. Okay, let us start. So we know that embedded system. So embedded means combining two things. So if you want to work with a laptop, we require two things. Either one is a OS, that is nothing but software, another is a hardware, like screen, keypad, touch screen, touch, all these kind of things we required. Mouse, touchpad, all these things we required. So this is a hardware. So if you want to make it effective utilization of your laptop, you require both hardware as well as the software. So this is called an embedded device. The best example is a laptop. So embedded systems is a microprocessor based computer hardware system, so which is consisting of both software designing to perform a dedicated function. So if you want to particularly do any kind of task or anything, then we are going. So in our washing machine also, like automatic systems are micro ovens. So all these are the one kind of which is having both hardware and the programming control structure. But the processor is different, the controller is different. If you are supposed to working with a processor like our laptop, I can able to do multiple tasks in a laptop. But in case of microcontroller, all these kind of things, I can able to control only a single thing. Like if suppose I'll write a code for the micro oven, so I have to use that. So must and should we have, where there is no another option, only for a particular single application we have to use one microcontroller. So it is being very complicated, right, for every device, every microcontroller, and there is no centralization unit in our home devices. So instead of that, if you are building any microprocessor regarding to the IoT devices, so that is nothing but a Raspberry Pi device. So, so by using a Raspberry Pi, we can achieve the centralizing unit. So, as a Raspberry Pi device is a prototype based, so which can able to present our ideas and which can able to build our things in a Raspberry Pi device. It's like a, to do any kind of prototypes on all these purpose. The real time applications we can able to achieve. Okay. So these are some prototypes we can able to build for an Internet of Things. One is a main Raspberry Pi. It's a, both processing features as well as hardware connections, controlling features also there. And then Jetson Nano, Intel Edison, Arduino microcontroller, and the Node MCU. So particularly if you're going to working with a Raspberry Pi device, you don't have any camera related applications, you just only sensor connection, connectivity, all these kind of activities. So then we are moving for the either Arduino or the Node MCU. But especially you want to do any object recognition or any face recognition technique or drowsiness detection, traffic. So any camera related or OpenCV related application, then we'll move for the Jetson Nano or Raspberry Pi device. Okay, so this is how the Raspberry Pi looks. So which is I'm going to see in a screen, that is a Pi 4 device. So a Raspberry Pi is a low cost a credit card size computer, like which is seeing look this. It is having an inbuilt ARM 11 architecture. So we know that ARM 11 architecture, ARM having different kinds of application. Even in your mobile phones also, we are using ARM processors only. So which will make you so many of applications you can able to build. So it is having a versatility of it can able to both act as a controller as well as the processor according to our requirement. So that's why for Raspberry Pi device, we are going to connect. I mean, we are going to use an ARM 11 architecture. So the IoT, IoT in the sense we have to connect the internet access we require. The first and foremost thing, internet. For what purpose? For creating communication purpose. And later we need to go. We have to collect some hardware related things like I want to control my light or I want to control my motor. So I need to connect hardware connectivity. So all these hardware connectivity are being done by using the GPIO pins, general purpose input output pins we are going to connect. So in a single word, if you want to tell about the Internet of Things, it is a combination of both embedded devices um, and sensors, and then some softwares and some protocols like SMTP and all these kind. The combination of all multiple these things we call it as we can able to build any internet of thing devices. So now we have in a raw process or something, so we have to make it fulfill, right? Like first we need to build a software, and then hardware connections we have to give. Later we have to write code to make it work, all these kind of things. Okay, first thing, hardware. We will see about hardware. So if I want to make this Raspberry Pi device, it's like a PC. You can able to connect monitor. So here mini HDMI cable is there. By using Raspberry Pi 4 device, you can able to connect two monitors at a time. Okay, you can able to connect two monitors by using these two mini HDMI cables. High definition multimedia interface. So if you want to make the Raspberry Pi connect to your monitor or a smart TV, we required VGA converter. Why? Because our monitor having VGA port, but here for Raspberry Pi device we have any mini HDMI port. So we required the converter to make it work. Okay, to connect to the monitor for display purpose, and then we have to connect mouse and keyboard. So here we have any two pairs of USB ports are there. So here in the two ports, one pair is about to 3.0 USB 3.0, and another pair is related to USB 2.0. So what is the difference between 2 and 3 is processing speed only. Like if you want to working with a memory card, if you want to transfer any data or anything, so then you just use USB 3.0, which will having the processing speed is high. So generally, but keyboard and a mouse you can directly connect here. So by using these USB ports, you can able to connect even web camera. And then this is for Ethernet. So for net connection purpose, Ethernet port is available. So this is a BCM processor, Broadcom processor. So and you can able to connect even power supply, I mean Pi camera this is. So the power supply, if you are supposed to take, this is a C port. Like in our mobile phones, so many Realme phones, all this having Oppo, they are giving C type chargers. So that C type charger is we have to give. So the Raspberry Pi can able to capable of 5 voltage power supply, and these are some different kinds of versions. So this is Pi B plus model. So how you are identifying this is a Pi 3 B plus model means on the top you can able to see like this. So this Raspberry Pi symbol represents this is a Pi 3 B plus model. So this is a Raspberry Pi 3 model. Any of the version not an issue, but if you want processing speed more, then we are going to upgrade ourselves. Okay, the latest versions, like in our laptops we have different kinds of versions, right? It is having a Raspberry Pi 3 having a inbuilt RAM up to 1 GB. Okay, but in case of Pi 4, up to 4 GB is there, inbuilt 4 GB. Like like our PC. Our PC also having 4 GB max now. Still, so many of them are using. And this is a Pi 2 version, and this is a Pi 0. So basically, Pi 0 when we are using means we don't want to work with any camera. So at that situations you can able to use this 50. So okay, we'll see. We are connecting monitor, we are connecting keyboard, mouse, and then net and audio. So this is an audio jack. Again, I'll show you. So this is an audio jack. We can able to connect. So we are done with all these connections. To make it this hardware work, we required software called operating system. So the Raspberry Pi having a separate OS called Raspbian OS, which is having a Linux operating structure. Okay. So either Noobs or Raspbian. First, we have to go to the official website raspberrypi.org. You just go there and you can able to see like this, Noobs or Raspbian. So everyone prefer instead of Noobs Raspbian. It's like a friendly environment. So it is having a Linux operating system, somewhat difficult. So Windows is a user environment, but a Linux operating uh, structures are basically somewhat developer environment. So initially we have to habituate ourselves. So then after, so here in a back side we have any memory card slot is there, right? So by how to dump the code in a Raspberry, I mean OS in a Raspberry Pi device means by using this memory card. So we have to use a card reader first to boot the OS. We have to flash the OS in a Raspberry Pi SD card. So in a backside, basically we are using either 32-bit or 64-bit. Max 64-bit is enough. If you are supposed to working with any camera OpenCV applications, then you just go through the 64 or 32-bit. Otherwise, 16 is also enough. Okay, according to our application, we have to choose the Raspberry Pi. I mean SD card. Sorry, SD card we have to choose. So first, we have to do one thing. I'll tell you the step-by-step process, just follow it. Okay, I already have that. Wait a second. So in our official website we gave you a link, so I just explain step by step. If you have any further queries also, you just go through that link. So that's why I'm showing you that link directly. Wait a second. First we have to format the SD card. So while running any SD card in your, I mean, you have before burn the OS or anything, first we have to keep it clean. So we require first softwares we have to download and OS. Okay. So what are the softwares we required? Softwares required for the booting a OS is SD card formatter and then Win32 disk imager. These are the two softwares you required. So where you can download it directly. So and it will open a dialog box like this. Make sure it is quick format and then after click on format. So it is very 10 to 15 seconds hardly it will take. So now open 32 disk imager. So this will look like this. When you are installing 32 disk imager, it will open you like this. So by using card reader, you just connect the laptop to that card reader to the laptop, and then after open a 32 disk imager. First format, then after open 32 disk images. So here we have to choose the file location. Which file location means where the OS is downloaded. So initially we are downloading, so here there is a OS process. Initially we have to download this OS card to your We give the power supply, and then it will be open automatically. 5 volts power supply we have to give. So all these are the things. This is pi 3, one HDMI port, audio jack, ethernet, and then USB ports, GPIO pins, general purpose input output. And then that means either we can use it as the input pins as well as output. The all sensors are comes under input devices, and all like a LED, motor, buzzer, all these are comes under output devices. So we can able to all these 40 GPIO pins are digital pins. Basically, all these 40 GPIO pins are connected to this BCM processor. So this is the main processor, Broadcom communication processor. And then this is in the back side we have in a SD card slot, which is previously shown here. So this is a SD card slot presented. So this is a BCM processor. GPIO pins. So while working with the GPIO pins, we have to make sure very clear, because all this pin configuration is somewhat different. So if you want to count all these 40 pin number, we have to give the pin numbers, right? So you have to keep the Raspberry Pi like this, which is opposite to the USB ports. You have to keep like this, which is shown in our slide. So from here you have to count like this: 1, 2, 3. Horizontally you have to count 1, 2, 3, 4, 5, 6, 7, 8. So likewise we have to count. Okay. So while counting all these 40 GPIO pin numbers, total 6 ground 10 ground pins are there, 2 inbuilt power pins, and then total 27 GPIO pins, remaining 13 are reserved pins like I2C or SPI. So SPI basically SPI communication for connecting another IC to the Raspberry Pi we are using, or I2C if you want to connect any I2C LCD display or these kind of things we are using. Okay, so special ICs you want to attach, then we are using this communication protocols, either SPI or I2C communication protocols we are using. Okay, so total these are 13 reserved pins are there. Remaining 27 are general purpose. All are digital pins. Okay. Uh, and then so now this is an architecture like we seen about um, power supply and then OS installation. Now our setup is ready. So now we have to uh, add Internet of Things to these devices. For suppose if you are connecting any LED, just simply write the code, all these kind of things. The things we required the cloud. So the Internet of Things is simply a network of internet connected to the object, can able to collect the data and exchange the data. Okay, like for suppose I gave the command turn on light. So first it should collect the information, so it should turn on, and then it should show the indicator like whether the light is turned on or not, we need to know. Okay, I am at office, I want to turn on my AC when I mean even I am at an office. So it will collect the data and it will able to execute, and then it should show the status of that particular device. Okay, the two-way communication it should be built. Or in a particular local in a particular situations, if you want to make it if you want to communicate any another devices, so then the network connectivity and the physical devices to the internet we have to make sure. So the industrial internet of things, the industrial internet of things refers to extending and use like for suppose if you want to run any home appliances or anything, and to not any home appliance, you just take your mobile in your hands, we have a mobile, right? So this mobile makes us more comfort, right? For suppose you are watching YouTube video now, now you are keeping your mobile phone horizontally. Initially we are working with an vertical, while watching a video you are moving it to the horizontally. So then the screen is also automatically tilt to horizontal. So how it will happen? So according to our convenience it will make us. So because of sensor availability, so the sensors make you more comfort, it will identify, it will sensing the information and all. So in a same way, so the simple mobile if you are taken in your hand, at least 10 to 15 sensors, inbuilt sensors are available. So if you want to make it any the whole industry in an IoT, So it is too hard to maintain all this data, right? uh, 200 sensors we have to accommodate, and all this data we need to maintain securely. Security issues also we need to take care. So this is all about the cloud connectivity. So we are, that's why everyone moving towards the cloud for transfer the data securely. Even it's not so easy to store in our local devices like memory cards or SanDisk, hard disk. All these kind of things is not so easy to store all the data. So that's why we are connecting to the clouds directly, and we are purchasing the cloud simply. So wherever we want, we can access the data. But suppose if you are store all the data in a local PC or anything, so they may be chance to destroy, right? So that's why we are giving cloud connectivity. In our day to day lives also, we are using we are using cloud, right? Google Cloud. So Google Drive, we are uploading all our photos, certificates, whatever, what are the requirements we have. So the it consisting of industry applications including robotics, medical devices, and software defined production process also. Even like even any sector, internet of things is must and should. uh, Now you draw some amount on in your account, so it will send you an SMS, right? The ATM machine send you an SMS, you have withdrawn 100 rupees or 10 rupees. The machine send it, actually some person is not there, the machine send an alert to you. So this is the internet activity. So the internet of things activity, the ATM machine should talk to us. Some unauthorized person is if somebody is wrong pin number 4 times or anything, it sends you a OTP for us. So all OTP aspects, all security things are nothing but internet of things. In a banking sectors, in a security aspects, you can use it. And home appliances, anywhere you can use it. In a smart classrooms, so we will see some different kinds of sectors and application. One is educational. So from a kid, if you are supposed to you want to send a kid to the schools, so one is tracking system, bus tracking system, whether the driver is uh, doing rash driving or a proper driving, we need to know. So that is GPS, it can be achieved by the GPS for tracking system. And then speedometer, speed estimation, so which will give you the driver speed accurately. And how many people are there. For suppose if you are some you are in a hurry early morning, right? If the school bus is coming to near, you have to time estimation also be required. So all these estimations are being done by using internet of things, the sensing element, GPS sensor. And healthcare applications. So nowadays we are facing so many issues, health issues or anything. We are not ready to go to hospitals due to this pandemic situation. So even you are going to the hospital, first they check the temperature, blood pressure, and then heartbeat, and even now oxidometer to check the oxygen levels in our body. So if you are making a wearable device, all these parameters are being monitored by the doctor. Thereby he can able to got some idea about your health, right? Is there any abnormal situations or anything? So very simple to identify to him. And if now the doctor no need to touch the patient, without touching the patient he can able to check the temperatures by using thermal scanners, all these kind of things. Instead of thermal scanner is so expensive, instead of this, a small wearable device, a sensor with a cost of 10 to 20 rupees, it should be very easy to doctor can able to monitor very easy. And then smart city, in a smart city you can build so many of applications like traffic management systems and air quality indexing. So the air quality indexing are presented now, as of now in a Delhi they are presented. And then a traffic management system in Andhra Pradesh, Vizag, it's the best place. First they are introducing intelligent traffic management system. For suppose if you are taking a four roads in a junction, if the north side is more traffic, then at that time the green light is turned on more time. So thereby they can avoid the traffic jams, all these kind of things. And then in a smart city you can able to build a dustbin, smart dustbin management system, garbage monitoring systems. And one of the major thing is an agriculture application. So in agriculture, first is smart data. like that particular weather and soil moisture data and the pesticides levels, or a drone. You can able to control the drone from here itself. And water stress, like how much water flow, pH quantity you can able to give, see. But suppose if you are taking commercial crops, whether the crop is ripened or not, we can able to easily, by keeping some cameras in and around the field, we can able to easily monitor. But the thing is, one major issue in agriculture issue, still there is a lot of scope here is, if you are supposed to take any crop or anything, it's hundreds of acres of land is there. So it's not possible to keep all the sensors in our entire field. And if your camera monitoring is also not possible in an entire thing, so thereby we need to do some kind of related research, and some we can able to introduce some different kinds of protocols which can accommodate each other. All these kind of things are being done by using, we can able to do by using an IoT and toll get management system. So now we are using already fast tags. So that is the best example for an IoT. And connecting cars, like from music you can play, and if your driver is drowsy, our car can able to identify, and the security somebody has stolen, so by using GPS we can able to track that. And for suppose your car should tell you your petrol level is going to be empty within 10 minutes, this is the nearest location petrol bunk, it should suggest to you. So the nearest petrol bunk, the vehicle itself suggests to me. That means what, my vehicle can able to talk to me because of an IoT device. For identifying the GPS, the location of the petrol bunks or anything, we are engaged with the GPS tracking systems. And another is music. Sorry, petrol level. So when the petrol level is less, then it will enable the GPS and it will able to identify, and it will send an alert to me. SMS notification alerts. If you are supposed to send an SMS, if you are depending upon again GSM or these kind of things, it's not, again it should be costly. The GSM cost is very high, right? About to 1 rupee per message, till up to 10 message, 100 messages only you can able to send per day. But in case of IoT, like you are depending upon Pillow Cloud, all these kind of things, there is an unlimited messaging systems you can able to build. And then lightning, like turn on, so voice control you can able to detect. And is there any truck suddenly came, it should give you an indicator. And traffic rules it will give you by giving the camera monitoring. And even it can able to capable of the camera, the person it will feeling drowsy or normal also, the vehicle should identify. And IoT in a transportation, like in a logistics, we can able to use. If you are supposed to go to new place, also nowadays we are not feeling that this is a new place. Till now I didn't went. I don't know it, because we are tracking everything on our mobile itself. GPS tracking systems are there. And the cloud. So the cloud computing is a one of the demanding availability of your computer system resourcing essentially. So just now I already discussed all this. For storage purpose, we are using a cloud, and security issues also. And what are the clouds we are using for an IoT is the best one, ThinkSpeak Cloud, and then Microsoft Azure Cloud, AWS Cloud, and then Google Oracle Cloud, IBM Watson Cloud. So they are introducing IBM Watson Cloud was introduced by the IB. Azure was introduced by Microsoft. So all these are some different kinds of clouds. And the protocol. So a protocol standard set of rules that allow you the electronic devices to communicate each other. So for suppose if you are taking machine to machine communication or these kind of things, these tools includes what type of data may be transmitting, and what commands are you have to use, and receiving which kind of data you are receiving. You should be particular about that. And how data transfers and connected to you. Think of a different kinds of protocols. The first protocol is SMTP protocol. It's very easy, simple mail transfer protocol. So nowadays in our day-to-day life we are so very depending upon these kind of notifications, right? Somebody, so officially if you want to send a mail, 100% if you want to send a mail, it's not so easy to send all the mails 100% at a time. So you have to type all the mail IDs, all these kind of things. So by most of the internet of things internet systems using SMTP as a method to transfer the mails from one user to another user. So simple mail transfer protocol is a push protocol, and it is used to send a mails, whereas POP, uh, post office transfer protocol, or IMA, IMAP, so internet message access protocol. So basically they are following the security encryption standard called TLS. So transfer layer security system they are using. We are using in a SMTP protocol. The SMTP is an application layer protocol system. So if you are supposed to working with a Python, so then it is so easy to build an SMTP protocol. So even I'll show you the code now. I'll show you the one demonstration, how to execute what is the code of an SMTP protocol. Wait a second. Okay. So now I'll just show you the demonstration of SMTP protocol. Suppose SMTP simple mail, it's like a application end. We can able to, suppose you're building a project, or you have an idea of a smart security system, of ATM smart security alert system, or a smart door lock system. Somebody are trying to knock you, I mean accessing your room or accessing anything. So either using Twilio cloud you can able to send, or by using send a mail to the particular person with an image. Okay, with an image if you want to send, so then we have to use SMTP. So I'll just show you the code on my screen. So first we have to import the library, SMTP library. So this is an inbuilt library. We have to import this. Sorry, in a Python we don't call it as a library. It's a module. Okay. So this is an inbuilt module, SMTP lib, and then I just take a variable. In that variable, yes, I store the SMTP lib function. So in a SMTP lib module, I have a function called SMTP, which should be all our caps. Okay. So in that SMTP function, I have a two arguments. First argument is the server smtp.gmail.com. Okay. So this is the main server, and then this is the port number 587. Okay. So now I'm going to start the server called, we have to follow the security method, right? Start TLS. Start TLS means we want to encrypt our data. That means that message can be seen by the sender and the receiver only. Third person can't able to see the data. So if you want to do like this, then we have to follow the security standard called TLS, transfer layer security standard. And then, so now I started, I follow that standard, and now I need to log into the particular mail ID, that is called sender mail ID. So if you want to send a mail, what you will do generally, we have to log into that, right? So now yes dot, so here why I'm giving every time yes, so here I just imported the whole SMTP function to yes variable, so that's why yes dot login. um, so here I created one mail ID with a password, so that username, and then user mail ID, and then password. I gave the user mail ID as well password, and then Now message is equals to how are you. I want to send this mail. Now I log into that particular mail. I'll write a message, and now s dot send mail. Okay, very simple s dot send mail, which is having this is from address, that means from Gmail, sender Gmail ID, and then this is a receiver Gmail ID, and then message. So message is equals to how are you. So you can directly you can write it here, but as just then after we have to quit the library. So s dot quit. So if it is send the mail successfully, then it should print mail sent, otherwise it should show some errors or anything. So now I just save this again, and now I'll run this code. Okay, now it will send mail. Again I'll open my Gmail ID and we will check it. See here it will send me, so this is the latest one. I didn't send any subject or anything. I just send a body called message called how are you. Okay, so here I type a message. See here, how are you. So the same thing it will send it to me. So here whether they follow any standard, we are following, right? So see here, security, standard encryption, TLS. Okay, so this should be make sure, because we have started the server with TLS. So mailed by gmail.com and signed by gmail.com. Okay, so the server port number should be two sides same, so that's why. So this is about SMTP protocol. If you want to explain the entire architecture very easily about SMTP, so here is the sender. Sender mail I mean send it to the sender mail server called SMTP. So in a code also we are importing, right, this mail ID smtp.gmail.com. So in that we have through this smtp gmail.com we are going to log in. Okay, so through internet from sender to receiver we are sending the SMTP, and then so either using a POP method or IMAP method we are going to send a mail to the receiver. And then here message queuing telemetry transport technique, MQTT. So MQTT is the best example for the machine to machine communication. So Internet of Thing connectivity protocol, it was designed and extremely lightweight publishing and subscribing. For suppose it is very similar like a HTTP. If you are supposed to take a HTTP, the main difference between HTTP and MQTT is it's a lightweight. MQTT is a very lightweight, we can able to send very simple data uh, over a particular range. And by what is the best activity of an, if you are supposed to take any Internet of Things like web pages or anything, local host we are majorly using. If we are supposed to use local host or these kind of things, what is the problem over there, like the Wi-Fi connected, the network connected should be same in a machine to machine communication generally in general. Like I want to control any device or anything using localhost, any web page, then the network connectivity should be same. All the devices, I mean my Raspberry Pi device or light, everything should be connected to the same network. Then only I can able to control. But if you are supposed to use an MQTT protocol, so without hesitating to different networks also we can able to connect. So because it's a lightweight publishing and subscribing messaging transport, so it is having a thing called publishing as well as subscribing. So publishing means those who are sending a mail, we call it as a publisher, and then receivers, those who are getting. But suppose if you are taking YouTube as an example, so in our channel we are publishing so many of different kinds of latest webinars or anything. So those who are subscribed to our channel, so then they can able to get notifications or anything, so then they got the benefit. So in the same way, from customer to I mean from publisher to subscriber, it is creating a some barrier. MQTT protocol, it's a lightweight protocol, whereas small code footprint is required and our network bandwidth is at a premium. So we can able to use different kinds of applications, logistics, security aspects, industrial energy management, the medical, in every cases we can use. But the best thing for an MQTT is I'll prefer in a vehicle, smart vehicle systems you can build in a particular location. You want to do, you want to collect all the information, and if you want to connect the Raspberry Pi and the Arduino as a different kinds of devices, the main server you are keeping, all the sub servers are there. So in that situations you can able to use MQTT. Even you can able to send two different Arduino to Raspberry Pi or Jetson Nano to any device, you can able to send the data. So I'll show you in a workflow here. Suppose here this is a producer. Producer is nothing but sender. Okay, those who are send the mail, this is, he is a sender. So he will producer send a message like I'll take an example. I want to turn on the light. So the Raspberry Pi device is a producer. So in a Raspberry Pi device can send a message called turn on light. So now this message being sent, so it should have a topic also. For suppose topic means it is a home light or a kitchen light or office, so we have to give some topic title we have to give. So for this particular message, what is the topic we need to mention. So this topic having different customers, like you can able to use it in the form of app or any another devices, like different lights are there, right? You can able to send it through uh, different kinds of device. The same message you can able to publish in a different consumers we can able to send it. So from producer to consumer, what is the main difference here? The topic and the broker. So broker is nothing but only which is a maintaining barrier between topic and the customers, which can able to send the same SMS to the multiple devices. So that is the main thing of working of a broker. Like what are the devices available are being connected to that particular topic, it will send a mail or anything. So even I'll show you the SMTP protocol execution also, the code explanation I'll give you. So here we have in two things. One is publishing side, as another is subscribing side. So here we have to install the module called PAHO MQTT module. We have to import. Okay, so if you want to install Paho MQTT in a Raspberry Pi device, so then we have to go through this sudo pip install Paho MQTT. We have to install this library, and then after import that library from the client side. So in a publishing means client send some information or anything. Okay, and then client MQTT dot client, I just stored in a variable called client. So and then connect to the main broker, I mean dashboard of MQTT main broker we have to connect. And 188 1883 is a server number and 60 is a port number we are connecting. This is a default. And then publishing. So we want to send some publish some information with a topic and a message, I mean that is nothing but command. So here my topic is Pantech and the command is hello everyone. Simply I'll just take it. Instead of that you can take home. Just take the topic is home light, home, and turn on light. Okay, turn on light, and then after disconnecting. So now I'll save this and I'll run this publishing code. Okay, I'll publish the data. So now in a subscriber side, they also subscribe to the same topic, not a different topic. We have to make sure they'll also, I mean in a publishing side, subscription side also they want to. So if you want to make this work, must and should we have to install the package Paho MQTT we have to install. So now, so we have to connect to the particular topic, right? So here I have in a previous topic. So I just want to change this topic as a home. My topic is now home. Okay, I have to connect it to that particular home data. And now on receiving a message from the which is published which is sent by the publisher. Okay, that message we want to receive. So here connect to the same broker. Okay, see here connected to the broker.mqqt dashboard. 1883 is the default and 60 port number. So the dashboard.com. So now I'll run here. So now see, it will publishing the, I mean it will subscribing to the publisher home. So that's why in a home publisher they have a command called turn on light. Okay, now it will pass the command turn on light. So it will give me so many of times because I run this in a infinite loop. So that's why it is showing now. Okay, so this is all about MQTT and SMTP library protocol. So this is all about this webinar. So had any queries, you just keep it in a comment section. I'll try to answer your questions. Thank you all. Thank you everyone having. So please fill the feedback form for certificate. You have to fill the feedback form properly. So then only you'll receive, you can able to receive the certificates. Thank you all. Uh,